Hello, this is Dr. Harrington, and today what we'll be doing is section 7.4, which deals with improper integrals. Alright, so here's how this works. Let's do an example. It's pretty intuitive. Suppose, for example, we want to find the area under the curve for y is equal to f of x, which is equal to, say, 1 over x squared, from x is equal to 1 to x is equal to b. Okay, so what this b does is it makes sure that this is a finite interval. So if I graph this out, so we can take a look at what this looks like. I have x and I have y, and I want to look at the graph 1 over x squared. This is the graph y is equal to 1 over x squared. Okay, and I'm going to integrate from 1 to b. Okay, so what happens? If I integrate from 1 to b of 1 over x squared dx, remember that's the same thing as saying I want to integrate from 1 to b. I'm just going to rewrite it just a little bit differently so it looks a little bit easier to integrate, dx. Okay, now remember what we're going to do is we're going to add 1 to the exponent, so we're going to get x to the negative 1, and then we're going to take the reciprocal of that, which is just negative 1. And we're going to integrate that from 1 to b. So that's going to be equal to negative b to the negative 1 minus, in parentheses, negative 1, negative times negative 1. Okay, which is going to be equal to 1 minus 1 over b. So what that says is that the area under the curve is going to be 1 minus 1 over b. So the area is going to be equal to 1 minus 1 over b. Okay, so the next question that pops up is, well, what happens as b gets large? So here's a question. What happens as we allow b to become large to infinity? Well, what that looks like visually, again, it's good to see what this thing looks like visually, is that we're going to have our x-axis and our y-axis, and we're going to have the curve. This is going to be the curve y is equal to 1 over x squared. And now I'm going to integrate from 1 to infinity. Okay, so this is what happens. So I'm going to take the limit as b goes to infinity for this integral from 1 to b for 1 over x squared dx, which this is going to be equal to the limit as b goes to infinity for 1 minus 1 over b. And what you'll notice is that this term just simply goes to 0, and I'm left with 1. Now, as far as notation is concerned, and this is how you should definitely read the notation, is that if you ever have to integrate from, say, 1 to infinity, if I ever ask you to integrate from 1 to infinity of something like 1 over x squared dx, what you're going to do is you're going to replace the infinity with a finite number and take that limit, like a finite b. So you're going to say take the limit as b goes to infinity from the integral from 1 to b of 1 over x squared dx. And this is essentially how you handle it. Is if I ever ask you to integrate from 1 to infinity, an indefinite, this is called an indefinite integral, by the way. This is an indefinite integral. Then you're going to convert it to a finite interval by looking at what happens as we stop at b, some number, and then take that limit as b goes to infinity. And that's how you compute a improper integral.